Hello class. Today we're going to be looking at problem F9-17, which states determine the magnitude of the hydrostatic force acting per meter length of the wall. Water has a density of 1 mighty large gram per meter cubed. 1 mighty large gram per meter cubed looks like about 1,000 kilograms per meter cubed. So here I've got a free body diagram. It shows a distributed load over this beam here that is submerged in the water. The beam has a height of 6 meters. Here's the surface of the water. I've got P1 right here at the very top, which means that's the pressure at the surface level of the water there. That's going to be 0 because it's not under any water. It's at the surface level. Then I've got P2 here at the very bottom, which is going to be the maximum amount of pressure at the very bottom. Over here, we've got the specific gravity is equal to the density times gravity. P1 is going to be that gamma times 0 because our depth is 0, which equals 0. P1 is 0. P2 is going to be gamma times 6 because that's our maximum height, and we're taking P2 at that max distance there underwater. Splitting that gamma up, it's going to be P2 is equal to 1,000 kilograms per meter cubed times 9.81 meters per second squared times 6 meters. Here we would have a multiplier for B for how far the beam would go into the paper. But since this question asks to find the force per meter length, we're going to just use 1 as our B today. So we can kind of just omit this. Once we multiply all this together, we're going to end up with 58,860 newtons per meter squared for P2. Next, we're going to find our resultant force. And to do that, we find the area of the triangle of the resultant force, which is going to be 1/2 base times height. So here I have 1/2. The base is P2, which we just found to be 58,860 newtons per meter squared, times h, the height, which is 6 meters. That results in a force of 176,580 newtons, or converted to kilonewtons, it's going to be 176.6 kilonewtons, but round that to 3 significant figures, and you will find your resultant force to be 177 kilonewtons per meter. And that will answer the question. Thanks for watching.